In this project, we're going to extend our understanding of arrays and use it to control the LEDs that are lit up on the 25 LED matrix. And we'll be using the A buttons and the B buttons to control which lights are lit up. Let's get into the Make Code editor. Buttons and LEDs. As always, the first thing we want to do is give our program a name, which is going to be LED in this case. Let's keep it short. The next thing we want to do is set up our array. Now, I'm just going to set up an empty array here. There are 25 LEDs, and the way that I'm going to refer to them in the array is just as we've got the first one, second, third, fourth, fifth. So we have a row of 5. And then on the second row, we're going to have number 6, 7, 8, 9, 10. And then on the next row, 11, 12, 13, 14, 15, and so on up to 25. So in the array, we can easily store a piece of information about every LED. And that will be, is the LED, well, should it be on or should it be off? Now, I can do that in the Make Code editor just by pressing choosing this and then starting out with all of these zeros like this and do 25. Instead, we're just going to start with an empty array and then we're going to go into a loop. And we're going to say for index from 0 to 24, because 0 to 24 is 25 items. Go back into the array. And you can see here we've got create, no, read, no, modify, right. Okay, at the moment our array is called list. So let's change that. LED indexes. We want to insert at position index a value. We need to create a variable. I'm going to create a variable called on. I'm going to create another variable called off. Right at the beginning, I'm just going to set off to 0. And I'm going to set on to 1. Here, I just want to start by having all the LEDs turned off. So I'm going to take off and put it in here. When the microbit turns on, it will show the string LEDs. It will then create a variable called off, which is 0, a variable called on, which is 1, and then it will create another variable, which is an array. Then we're using a for loop for index from 0 to 24. Well, index here just means inside this green block, wherever we use the word index, it'll be 0 the first time it goes through, and then it'll be 1, and then it'll be 2, and then it'll be 3. So it's just going to repeat it, incrementing that index by 1 each time, just starting from 0. Well, to start off with, the index is 0, and it will insert the value off, which is 0. And then it will go through the loop a second time. It will change index to 1, and it will insert at the index 1 inside this array, LED indexes, the value 0. And so in this way, we're just going to have an array which is 25 zeros, which is actually exactly what we want. We also want a way of recording which index we're dealing with. So we're going to make a new variable and call it current index. What we want to happen is when you press button A, we want one of the lights to light up. So we want to change one of the values inside the array from a 0 to a 1. And we want to just set current index to 0. We want to use the A button to flip the LED on, change it from 0 to 1. We need to go into arrays. And because we're changing one of the variables here, we need to go down to modify. We want this. Our array is called LED indexes, of which position in LED indexes It's the current index. We want to change that value from off to on. And now we want to increase the index by 1. So we are also going to change the current index, doing the typical thing that we've done before, to the current index value plus 1. The problem with this is if the current index goes over the value of 24, then nobody's really going to know. We want it to be that if you press button A, it will not change the index to 25. And to do that, we just need to put this code into a logic check first. We just check if the current index is less than 24. Well, okay, in that case, you can still increase the index again. If you press button A and the index is already 24, this will not be true. And if this is not true, then the microbit will just skip over that code and you can see there's nothing else below that. But we'll have button B to deal with that a bit later. Well, now we want to get the computer to turn on or turn off the LEDs. And to do that, we are going to use another loop. We're going to say for index from 0 to 24. And then what we're going to do is we're going to divide the information that we've got into two things. We're going to look inside the LED indexes array. And if the number is 0, then we want to turn off that LED. And if the thing that we pull out is on, then we want to turn on that LED. And then everything that's a 1 we can put into this first part, and everything that's not a 1 can be processed by the second part of the program. We need to find out if something is equal to 1. Well, again, we need to go into the array, and we need to look in our LED indexes array. We want to get the value at index. Now for here you can see this has got a bit of a different surrounding pattern. It's not a solid line but a dotted line. In this case we could just grab this index and we can put it in here. We can start to use the LED block. The two blocks that we want to use from the LED block are plot and unplot. For plot we're going to put this in here because anything that passes this logic check, in other words, anything where the information that we pull out, it is equal to a 1, we want to plot that information. We're just going to do that by, again, copying the index here and just putting that into X. The way the microbit works, X goes across and Y goes down. The first position is X equals 0. Then it's X equals 1, X equals 2, X equals 3, and X equals 4. And this is all for Y equals 0. Now for Y equals 1, we have to go down onto the second line. And then again, it's X equals 0, X equals 1, X equals 2, and so on. So it's a little bit different from graphs that we might normally draw. It starts in the top left, and the coordinate for that is 0, 0. And then it's X goes across and Y goes down. If the value that's taken out of the LED indexes box is not 0, well, in that case, we will unplot the point, because otherwise the microbit, in this case, will just leave the LED turned on, and we'll just put index into there. We can use the simulator to check if this is going to work. It's saying LEDs, and now if I press A, it lights up the first one. An A, an A, an A, and then it keeps lighting them up. Oh, we haven't defined B yet. We can just copy this whole thing for B, and then we just need to make it the reverse. So I'll change this to B. If the current index, in this case, because we're going to be counting down, we want to know if it's greater than 0. That means it must be 1 or 2 or 3, but it can't be 0. If it's 0, then this logic check will fail, because it will not be true that if the current index is 0, 0 is not greater than 0. So it will not do the code inside. And then in this case, we want to turn them to off. And then we want to decrease the index by 1. Okay, let's look at the simulator. LEDs, right? We press A and they start lighting up, and then we press B and they start going down. Okay, so far, although this is just for one line, we can extend this to make it for multiple lines, but it gets a little bit more complicated in that case. But we've successfully used an array to track this information. Let's download it. Make it bigger. Make it smaller. There we go. Now you'll notice if you look at the code here that we have an interesting little problem. If I press A, it increases by 1. But when I press B, it doesn't immediately decrease. I have to press B again, and then it starts to decrease. And then when I press A, it doesn't immediately increase. I have to press it again. This is a bug in our program, because really that's not what we want to happen. We want it to be that A just increases and B decreases. I'll show you how we can solve this particular problem. Looking at the code that we've got here, our current index is set to 0. And then what happens is when we press A, it will light up the LED at 0, and then it will increase the index to 1. If you press it again, it will go back through this loop. So it will light up the index at 1, and then it will change the current index to 2. So now let's say we've got LEDs 0 and 1 lit up, but our current index is actually number 2. Well, if at this point we press B, then it's going to turn off the LED at index 2, which actually isn't turned on in the first place because we've only turned on the LEDs at index 0 and 1. So the first time you press B, it turns off something which is already turned off, and then it decreases the current index by 1 to 1. Gosh, that was a bit confusing. If you press button B again, it will turn off the LED at 1, which is turned on, and then it will change the index to 0. The way to solve this is that when we start, we do things in an opposite way. When we press button A, if we change the index first by increasing it, and then we turn that LED on, then the current index will be the LED that we just turned on. Then when we press button B, if we turn off the current index first and then decrease the number, then it should happen that you can press button A, and the first thing it will do is increase the index before toggling the LED on. This means that when we start, we need to start with an index of -1, because when you press button A, it will increase -1 to 0, and then it will turn on the LED at index 0. So let's see if that works. Over in the simulator, if we press A, you can see light up, light up, light up, light up. And if we press B, it turns it off. And if we press A, it turns it on. Great, we debugged that part of the code. The next problem is this. Oh, we've got 5 LEDs now. So the next LED that I want to light up is on the next line. But if I press A 1, 2, 3 times, it seems that nothing is happening. And if I press button B 1, 2, 3 times, nothing is happening again. Now, if I press button B again, you can see I start decreasing the number of LEDs that's alight. And that's because we have another problem with the code, which is if we go into this forever loop, it never changes the value of Y. It only changes the value of X. It keeps trying to turn on LEDs that are not there. We have a row of 25 pieces of information, and we need to chop it every 5 pieces and start lighting up the next row, and then chop it and start lighting up the next row. Well, how can we do that? Fundamentally, in our forever loop, we are checking every value in our LED indexes to find out is it turned on or is it turned off. But inside each of these loops, we need to now do another check. So go into logic, get the logic check out, and then put that inside the first one. In this case, this logic check is only going to apply to LEDs that should be turned on. So what we're going to do is we're going to check to see what the index is. And it's quite simple, really, in a way. If we have index 0, 1, 2, 3, 4, that applies to the first line. If we have index 5, 6, 7, 8, or 9, that applies to the second line. So we need to change that into an X and a Y. First, we can just check if it's very full. If that index in LED indexes is bigger than 20, then subtract 20 and plot the result. Let's say the index is 21, then first we just check, is the index bigger than 21? If it is bigger than 21, then subtract 20, and that will leave 1. And 1 is not the first, because that will be 0, but is the second LED along for the x-axis. Also, because we've subtracted 20 successfully, we'll know, that must be in the last line, because we don't need to subtract anything. In the second line, we need to subtract 5. In the third line, we need to subtract 10. In the fourth line, we need to subtract 15. And in the last line, we need to subtract 20. First, we will check if the index is greater than or equal to 20. And then if it is, we want to plot that point, but not that point, because that index, if it's greater than 20, could be 21. We need to change that into a number between 0 and 4. We need to do some maths, get the maths block out. We'll need to take the index and subtract 20. We know that this is all for the last row. So we know that for all of these LEDs, it's going to be row 5, which is index 4 for Y, 0, 1, 2, 3, 4. Now that's essentially what we need to do. That covered the very bottom row, so now we need to cover the fourth row. Let's open up another if statement, and we need 5 rows here. So 1, 2, 3, 4, 5. Okay, I'm going to copy this comparison, and then I just need to reduce that by 5 to 15. I'm going to copy the plot. I need to reduce that by 5 to 15. And also this is for the fourth line. Then I need to do the same thing again. And then finally, we don't need the comparison, because we're just saying in every other situation, which we know must be from indexes 0 to 4, you need to plot the index on y equals 0, which is the first row. But in this case, we don't need to subtract anything, so we're just going to take index out there and put that there. Throw that in the bin. We can just test this now. If we look in the simulator, I'll press A, and you can see it lights up. Well, we've got 5 LEDs. What's going to happen when we press the next one? It works. Okay, and you can see as I keep pressing A, it just keeps increasing that number. So that's great. Everything is working as we expect. And we can keep going until we fill up all of the LEDs. At the moment, we can't decrease them, though. We haven't changed what happens when the value that's stored in the array is a 0, is turned off. But essentially, it is exactly the same as this if block here. So I can duplicate this, and I can put it inside. But instead of plot, I need unplot. So I'll take out that last one there, because that's exactly the same. And I'll throw that in the bin. And then it's just a case of copying everything over. So there we go. We have it. Flashing, flashing, flashing. Whoa, look at that. And we can go all the way. And then we can go all the way down. Brilliant. So there you go. In this project, we used the buttons to change information which we stored in an array, which was a way for us to organize whether each of the 25 LEDs should be on or off. We're going to move on now to the two big projects, which are two games that are using a lot of the code that we've been learning. So I hope you stick around for that.